in the documentation, and I can't confirm nor deny what page this is on. But I know we do have this one. I have seen this one in the catalog. It'll be in the CCD section somewhere, showing the proper piping of CCD, both two-way and three-way. Three-way zone valve. These are used exclusively in diverting applications. Water enters through the bottom, the AB port, and exits out either A or B. And again, within the zone valve section, there'll be information on the proper way of piping and then the improper way of piping. You can see up there with the actuator below the valve. It should pipe it that way. Three-way mixing butterfly valves. You've got an inlet port, which is your master, outlet ports, and slave and common ports.
So those are linked together, so it's going to be equal flow from either direction, or the independent?
Right. Nope, you're correct. They're linked together,
Okay.
and yep, they move. One valve will be open, the other will be closed, and then they'll move in between the mix, and then eventually the other will be open. So they're just talking here about a typical hot water mixing application. Master port up here will be connected to the boiler, allowing the hot water to flow. Hot water return connected to the slave port. Like I said, both ports are modulated. Same valve can be used in a diverting application. Now this is true only of our standard EPDM line butterfly valves. When we start talking about high performance, then it's a different valve body that will do mixing and diverting. So when we're using it as a diverting application, your inlet port is your common port, and then you're going to either go out that slave or the master. And there can be different settings. You know, on the right over here, that's not always going to be the common. If you have a different setup, maybe the left side is common, or maybe third port there is common. In our documentation, when you go to order a three-way butterfly valve, Jackson should be asking you which port you want it to be the common port. And because they will be asked when they place the order with Belimo, which port is supposed to be the common port. And in the butterfly valve section, we have a chart that shows the various configurations that are available. Typical application would be on a cooling tower connected to the chiller condenser water supply. So flow can be diverted to any of the outlet ports, either the slave or the master. These are the charts I was speaking about. You can see here the various configurations for the standard butterfly valves. Over here we have extra configurations, because like I said, these are for our high performance valves. And if you're using a high performance valve, mixing and diverting is going to be a different valve. So you have the different configurations for mixing, different configurations for diverting. Six-way valve. Talked about this a little bit earlier. It's designed primarily for chilled beam radiant panel applications, where you have 4-pipe design doing heating and cooling. So, for example, sequence 1, the left side of the valve is a 0 to 30 degree angle. So I don't know what you may have thought when you first saw it. The first time I saw the valve is, I thought top would be used for one thing, bottom would be used for something else. That's not the way this valve works. The valve works where this is half and and then this is the right half. And the third port coming out the middle, those are your counter ports. So from 0 to 30 degrees, you would be flowing through these ports. 30 to 60 degrees, you're going to be in the middle, and everything's going to be closed off. You're not going to be heating or cooling. Then sequence 2, your 60 to 90 degree rotation, you're going to flow through the right side of the valve. These ports here, whether it's heating or cooling, doesn't matter. But like I said earlier, you can select different CVs for each side. So this is just showing how it can be used. This is using just 2 valves. Down here, some advantages, disadvantages. Optimum exchanger, installation cost of the exchanger is a negative. 2 control sequences because we have 2 coils. Cost is optimized through the exchanger by having both heating and cooling through the 1 coil. Installation cost of the valves here because now we have 4 valves and 2 control sequences. Whereas when we install the 6-way valve, then we've got an optimized exchanger because we're doing heat and cooling through the same exchanger. Low installation costs. We only have the 1 valve. Lower controller, that should say output. You only have to have 1 control output. And then the unit price of the valve, it says that's a negative. It's a negative if you compare 1 to 1. But if you have to buy, say, 2 standard valves, 1 of these is going to be less expensive than 2 valves. So just the solutions using these in the chilled beam applications. Let's see, similar scenario here. Got 2 valves there, then a 3rd valve, it's a switching valve. And then we get down here where we're using the 6-way valve again. With the same type of benefits, lower installation costs, only 1 controller output. Hey, there it's spelled right. Yeah, this is supposed to be a little animation thing, but when I tried it last night, it did not work.
Are the ports still marked A, B, and AB?
That's a good question. I believe they are. I believe we have yeah, A, B, and AB on both bottom and top. I believe is the way it's set up. Like I said, this was supposed to be animation. I can't get the animation to work, but it would be showing you the flow. First, it would show you the flow of the heat when using it in the heating application. Then it would turn around and show you the flow of the cooling application. You can basically see how it runs based on the arrows. Unfortunately, the animation isn't working. Really, it's my computer, I think, that isn't working properly. So you can read German, that says heat zone. That says cool zone. I don't know what that says. Probably energy free, I would assume. But that's where the dead band is in that 30 to 60 degree range as we were talking about on one of the earlier slides. Any questions on that section before I move on? No? Okay. Well, we'll talk about power and control a little bit then. Talking about direct acting and reverse acting. Explaining the setup of a valve is normally open, normally closed, and open, closed. So if we're talking about direct acting, that means as the variable goes up or in one direction, the output correction also goes in that same direction, as you can see here. Temperature is increasing. Uh-oh, somebody just bought a PS100.
Where they're really cheap.
Yeah.
Yeah, not so much.